over A86 speed of sound. Just like all other mechanical waves, right? Speed of sound also use a medium, right? Now, speed of sound moves faster in solid and then a liquid and then gas, and that's what we're going to prove, right? Speed of sound moves about 5,000 meter per second in the solid like steel, and about 1400 meter per second in the liquid, right? And about 331 meter per second in the air if the temperature is 0 degree. But if temperature increases, right? For example, today's temperature is 59 degree Fahrenheit, then the speed of sound also would be increases. So that's what we're going to prove, right? So let's get it started. Let's first we're going to write speed of sound, gas, liquid, and solid. The case study, let's do a case study. For gas, we're going to use air. For liquid, we're going to use water. And for a solid, we're going to use steel, right? Okay, good. How the solid made of? Like solid is, atoms are tightly bonded, just like this, right? Very tightly bonded. And atoms are loosely bonded in the water, right? Atoms are loosely bonded. Okay, so this is a rigid or stiffness. All right, this is less rigid. If this rigid or stiffness is about I don't know, about 100%, right? This stiffness would be about 50%, right? And gas has no shape or size. The stiffness would be 0. Would be 0%, right? Okay. Now, one thing we know is also going to depend on density. We're going to use rho for density. And density, 100% in the solid, density is about 50%, and density, there is no density, gas has no density. Okay, now, few other things. If the stiffness, rigidness go up, the velocity also go up. If the density go up, the velocity go down. However, the rigidness contributes to the velocity more than the density. Okay, so the equation we're going to use for this one, well, the gas made up, if I write all the atoms, let me write some of the atoms: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon, and all the way to, you have gold, and all the way to argon on the last element on the periodic table. Okay, so the gas made of three of the elements, and that is nitrogen, oxygen, and argon. Okay, and then we're going to be talking about that. And for velocity, velocity square is equal to bulk module. So we are talking about bulk module over pressure, right? So what is bulk module? Bulk module, so bulk modules is an object ability to withstand, right? An object ability to withstand the change in volume when it experiences pressure forces from all direction. For example, you take a shape an object and submerges inside the water, then it will experience forces from all directions. So the bulk module is that object ability to say no to any change in its volume, right? Okay, so bulk module, we're going to use B, right? B for bulk module. Sometimes people use P for pressure, and bulk module as a unit would be Pascal, right? And we also going to use the density. Density we're going to use a symbol rho for density, and as a unit for density we're going to use kilogram cubic meter, right? Okay, now B square is a bulk module. Let's say the bulk module for solid is really high, 2 times 10 raised to 11 Pascal, and the density for solid is about 8,000 kilogram cubic meter, right? And bulk module for liquid is 2 times 10 raised to, let's say, 9 Pascal, and the density for water is 1,000 kilogram cubic meter, right? And the gas, the bulk module is 0, and the density is also 0, right? Ideal gas density is 0. We're talking about ideal gas, we're talking about air. Okay, so the bulk module is 2 times 10 raised to 11 Pascal. So what is Pascal? Kilogram meter per second square. We probably going to have to do the density, and density is 8,000 kilogram cubic meter, right? So now notice that meter goes to meter square times, and then you have a kilogram cancel, and 2 divided by 8 times 10 raised to how much? 11 minus 3, so it's going to be 8, right? Meter square over second square. Right now is 0.25 times 10 raised to 8 meter square over second square. 2.5 times 10 raised to 7 meter square over second square. Square root of this is going to give you 5,000 meter per second. So the speed of sound in the solid is 5,000 meter per second. Now we're going to find the speed of sound in the water, right? So the speed of sound in the water, we're going to be using the same formula, because water has what do you call the bulk module and density. So the bulk module for water is how much? 2 times 10 raised to 9 Pascal, and the density is 1,000 kilogram cubic meter, right? So V is equal to 2 divided by 1 is 2 times 10 raised to how much? 6 Pascal. What is Pascal? Pascal is kilogram meter per second square, right? And this cubic meter. So meter square, kilogram cancel. So meter square over second square velocity. So velocity is 1,400 meter per second. Now we're going to do it for the air. So we're going to try to find the speed of sound in the air. So for solid, it is speed of sound is 5,000 meter per second. For liquid water, it is 1,400 meter per second. Now we're going to try to understand for the air. Air made of 3 element, carbon, oxygen, and argon, right? Okay, so nitrogen has 7 atomic number, 14 atomic mass, atomic number. So let's say carbon atomic number, atomic mass. Atomic number is number of proton, atomic mass is proton plus neutron plus electron, but electron is almost 0. The mass of electron is almost 0. So proton plus neutron, that's it. So for carbon, this is 6, this is 6, and this is 6. So for carbon is 6, 6 plus 6, 12. Okay, good. And for nitrogen it is 7 and 14, oxygen this is 8 and 16, and for argon this is 18 and 40. Why it is 40? Okay, so argon has 3 isotope. So what is isotope? Let's define those things. First we're going to do element, and then atoms, and then ions, and then isotopes. Okay, so element, this is an example of element C6, 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 C12, C13, C14. So although they are although this one is isotope, this one is isotope, but they all are atoms, they all are elements, right? Because they all are carbon, so they all are elements. Example of element, example of atom. This one is example of atom, C612. Why? Because it's meet the condition to being atom. 2 condition: proton has to equal to be number of neutron, right? So 6 proton, 6 neutron. Okay, check. Proton also has to be equal to number of electron. Check. How many electron? 6. How many proton? 6. Okay. Ions. This one is sodium. Sodium has how many? Sodium has how many? Okay, so sodium and chlorine, so can make sodium chloride. So sodium has 11. So let's draw sodium. Sodium has 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 proton in the nucleus, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 neutron in the nucleus. So sodium, the first shell, sodium has 2 electron, 1 electron, 2 electron, right? So altogether 11 electron, so 9 more electron. The second shell only can take 8 electron. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, the third shell, how many electron left? Just 1, right? So this is called valence electron. Valence electron. All right. So now let's write sodium. Sodium. If the sodium lose that electron, and sodium wants to lose that electron, nobody likes 1 electron in the outer shell. We're going to be probably talking about that. Okay, so sodium 1 plus, so charge is proton minus 1. So proton is 11 minus 1, so 10, right? So proton is 11, electron is 10, right? So it is positively charged, right? It's positively charged, so it's cation. Cation. Okay. Now isotope. Let's talk about the isotope now. This one is isotope. This one is isotope. For example, C613. C613. Why? The proton is not equal to neutron, right? More neutron than proton, so it's an isotope. Okay, good. Now argon has 3 isotopes. So argon has 3 isotopes. Argon 18, argon is 18. That's argon atomic number. You cannot change the atomic number. However, this is argon 36, this is argon 38, argon 40, right? Argon 40 is 99.6%, about 99.6%. This is about 0.2%, and this is about 0.2%. Okay, so what is argon atomic weight? Atomic weight. All right, atomic weight is you have 40 times 0.996 plus 38.002 plus 36.002, and that is atomic weight should be around 40, but let me check. 40 times 0.996 plus 38 times 0.002 plus 36 times 0.002, and that is that is 40. So now, as we said, the air is equal to what? Air is equal to nitrogen gas plus what? Oxygen gas plus argon. Argon is the noble gas, it doesn't react with the other atoms, so it's by itself. Okay, now this is atoms, nitrogen atoms, oxygen atoms, and argon atoms. And nitrogen atoms, this is nitrogen has 7 atomic number, 14 atomic mass, 8 atomic number, 16 atomic mass, 18 atomic number, 40 atomic weight. Okay, so atomic weight, not atomic mass, atomic weight. Okay, this is how we can find the atomic weight, because there are several type of argon isotopes exist. Good. Now we're going to find from atomic weight to molar weight, right? Molar weight. So molecule, one atom, when you find the when you find the weight of from just one atom, you call it atomic weight. And when you find multiple atom involved, there are 3 type of atom involved. What are they? Nitrogen, oxygen, and argon. So you call it molecule molar weight. So molar mass or molar weight, molar mass is equal to, all right, so now we're going to write, this is, by the way, this is this one is 78%, this one is, I don't know, 21%, and this one is 1%. All right, so now we're going to write 2 times 14 times 78 plus 2 times 16 times 21 plus 1, this is 1, this is 1, so 1 times 40 times 0.01. So molar mass is equal to 29 gram per mole. We don't want gram, we want kilogram. So molar mass is 0.29 kilogram per mole. But let me see, I am trying to divide by 1000. 29 divided by 1000 is 0.029 kilogram per mole. But I want to check this calculation as well. So 2 times 14 times 0.78 plus 2 times 16 times 0.21 plus 40 times 0.01 is 29. Okay, good. So this molar mass, now we almost there. So to find the speed of sound is you have gamma, which is heat capacity, and then you have R, which is His constant, and you have T, which is temperature in Kelvin over molar mass or molar weight. So this is 1.4, this is 8.3 joule over Kelvin per mole, and joule is kilogram meter square over second square. Temperature, we're gonna have to do the temperature now. Temperature right now is 59 degree Fahrenheit. So 59 degree Fahrenheit. So Kelvin is equal to 273 plus Celsius. So Celsius is 5/9, Fahrenheit minus 32. So 5/9, 59 minus 32. So 5/9, 27. So it's 15. So K is 273 plus 15. So K is 288 Kelvin. Okay, so we now know K is 288 Kelvin, right? And molar mass is 0.029 kilogram mole. Kilogram on the top you have mole. Okay, now we want to cancel a few things, hopefully. Okay, so what can we cancel? We can cancel Kelvin, Kelvin. We can cancel mole, mole. We can cancel kilogram, kilogram, right? So V square is, you have 1.4 times 8.3 times 288, everything divided by 0.029, and don't forget to take the square root, and that gives you 339.7. So I'll say 340. So velocity is 340 meter per second. All right. This is how you calculate the velocity of sound in the air at today's temperature, 59 degree Fahrenheit. Now we want to discover something, and that is, as you know, that if you increase 1 unit, right, if you increase 1 Celsius, then the temperature would be what? If you increase 1 Celsius, then it's going to become 341 Celsius. From 59 to 60, then it's going to become 340.6, right? If you decrease 1 Celsius, then it's going to become 339.6, right? Okay, that's what we want to do. We want to discover. We want to find another equation which is equivalent to this. So by using y equal to mx plus b, right? We know our b, 331. We know our y, that is a velocity of sound. We know our x is temperature in Celsius, right? Temperature in Celsius plus 331. Good. Now we need to find m. How can we find m? Well, we're going to plug in two things. This one for 1 degree Celsius, and this one for the other one is for 2 degree Celsius, right? Okay, so 1 degree Celsius, I'm going to do it here. For 1 degree Celsius, and this is 2 degree Celsius. 1 degree Celsius, what is going to be? 1.4 times 8.3 times 273 plus 1, 274, divided by 0.029. This one, 1.4 times 8.3, 273 plus 2, 275, divided by 0.029. Okay, let's see what we get. So 1.4 times 8.3 times 274 divided by 0.029 square root and that is 331.34. 331.34. 331.34. All right, now we're going to do the other one. 1.4. 1.4 times 8.3 times 275 divided by 0.029. Don't forget to take the square root, and that is 331.94. 331.94. Okay, so you have at 1 degree Celsius you have 331.34. At 2 degrees Celsius you have 331.94. So what do you discover? You discover if you increase the temperature, you get if you increase the temperature, the velocity also increases, right? How much increases velocity? 0.6, right? And if you decrease the temperature, 1 degree Celsius is equal to 331.34. 2 degrees Celsius you get 331.94. You get negative 0.6, right? If you decrease the temperature 1 degree Celsius. How can we use this one to write the equation? Okay, very simple, right? So you're going to write velocity of sound is equal to you have slope now 0.6 t, which is in Celsius, right, plus 331. Now we can check it, right? Before we knew that the 15 degree Fahrenheit is 340, right? 15 degree Fahrenheit, no, 59 degree Fahrenheit. So 59 degree Fahrenheit is 15 degrees Celsius. So 15 degrees Celsius plus 331. So yeah, this is going to give us 340, right? This one going to give us 340. This one also going to give us 340. So about 1.65 kilometer away from the train, right? So I was here. All right, and then the Isaac was also here, right? Now, what Isaac did, we want to know how long it's going to take for the train to arrive here from here. So what Isaac did, he get close to the rail track like this, and he heard the sound using his ear. On the other hand, I just stood there and I thought that I would get the information anyway, right? Now the question is, who get the information faster? So let's see. Me saw ear. I use the ear as a medium. Isaac used the solid as medium. And the ear speed of sound is today, right? So we're going to use 340 meter per second because it's 59 degree Fahrenheit today. And the solid speed of sound is 5,000 meter per second. Converted to SI unit 16500 meter. Velocity is lambda times frequency. Velocity is lambda times frequency. Let's see who get the information faster. So the frequency is 1 over time. So velocity is lambda over time. So time is equal to lambda over velocity. So lambda is 16500. Velocity is 5,000. So Isaac get information about 0.33 second. On the other hand, it took me forever to get the same information. So the time is velocity over lambda, right? The time is lambda over velocity. Lambda over velocity. So lambda is 16500 500 and velocity is 340, right? So it took me 5 seconds, right? So knowing physics makes you smart. It took him less than 1 second. It took me 5 seconds. So knowing physics really helps.